tendency of a conservative force is to decrease the potential energy. What does that mean? The tendency of a conservative force is to decrease the potential energy. Can you visualize what that means? Well, I think I need to explain that. Now, let's consider a basketball sitting on the floor. There, it's sitting on the floor. Now, we say that the earth and the basketball, these are two objects. One is the earth, other is the basketball. Let me see if I can draw that for you. Now, here is the earth and here is the basketball. We say this system, which is called the earth, the basketball system, there are two objects. Now, this system has a potential energy U. What happens when I lift the basketball up? Look at that. I'm lifting the basketball up. What did I do? I increased its potential energy. So, if I take this basketball away from the surface and keep it there, I am increasing the potential energy of the system. So tell me, when do you have the potential energy of a system the least? When they are closer together or when they are farther separated? The potential energy of two objects is the least when they are very close together. So when the basketball is on the ground, the Earth's basketball system has the least potential energy. When I move the basketball up, I do work on it, increasing the potential energy of the system. So, what is the sentence which I just read for you? The sentence is, the tendency of a conservative force is to decrease the potential energy. What does that mean? You see, when I lift the basketball, the force of gravity tells the basketball, hey, you, come back. Isn't it? The moment I leave, it goes back. So what is the tendency of a conservative force? The gravitational force is a conservative force. That means, if I raise the basketball, the conservative force, which is the Earth, the gravitational force, does not like it. It wants this ball to be back on the ground so that their potential energy is zero. The tendency of a conservative force is to decrease the potential energy. Now look at this, the spring. When I stretch it, its potential energy increases. Now, you know, when I stretch a spring, the restoring force of the spring is pulling it back. It says, come back. Let's have least potential energy. The restoring force of the spring is a conservative force. The tendency of that conservative force is to decrease the potential energy. A very important concept. So let me say that again. What is the tendency of a conservative force? A conservative force always wants to keep the potential energy of systems the least. Earth attracts all other objects towards its center so that the potential energy of the Earth object system will be the least. The tendency of a conservative force is to decrease the potential. So the gravitational force pulls an object towards the ground where the potential energy is the least. A compressed spring has potential energy U equal to 1/2 kx squared, and the restoring force of a spring tends to restore the spring to a state of zero potential energy. Therefore, work done by a conservative force always causes a decrease in potential energy. And whenever you want to denote a decrease, we will use a negative sign. Is that right? So, work done by a conservative force. If W is the work done by a conservative force, its tendency is to decrease the potential energy. W equal to negative U. Well, does that make sense? Yes, the work done by a conservative force always decreases the potential energy. Work done by a conservative force equal to negative of the potential energy. Now, this is the same as saying that the increase in potential energy equal to negative of the work done. Is that right? If the work done is a measure of the decrease in potential energy, then the increase in potential energy equal to negative of the work done. Potential energy is the negative of the work done by a conservative force when an object is raised from a height h1 to a height h2. And so, in calculus, we can write it like this. Potential energy equal to negative of, look at that, negative of the work done. Work done by what? Work done by this conservative force, which is negative mg. So potential energy U equal to negative of the work done by the conservative force, which is integral h1 to h2 negative mg dy. And that will be mgy from h1 to h2, or you can write it as mg times h2 minus h1. If this h2 minus h1 is equal to h, then potential energy equal to mgh, or we can now call it mgy, because h2 minus h1 is the distance y through which the object is raised. So potential energy equal to mgy is the same as the first equation that we obtained, potential energy equal to mgh. Let's now talk about kinetic energy. Another form of energy is kinetic energy. What does kinetic mean? Kinetic is related to motion. So kinetic energy is energy related to motion. Work done on an object can produce motion on the object. That means a moving object has energy. A force F acting on an object of mass m displaces it through a distance x, giving it a velocity Vf equal to v. Let's picture that. We have an object of mass m here, and a force F is acting on it. Well, remember, a force acting on an object will produce an acceleration on the object. And if there is an acceleration, its velocity will change. So the object now moves to a distance x, acquiring a velocity v when it comes here. So the initial velocity of this object is 0. When the force F acts on it, it moves through a distance x, acquiring a velocity v. Alright? Now, you have this equation, everybody knows this, v squared equal to v0 squared plus 2ax. This v is the velocity it acquired in moving through a distance x, and v0 is 0. Can you solve for a, the acceleration? Well, we have v squared equal to 2ax. And so let's solve for x. X equal to v squared over 2a. Alright? What is the work done by this force? work done by this force on this particle is the force multiplied by the displacement. So we can say W equal to F multiplied by X. And now we can replace this F by MA. Is that right? It is the acceleration produced by this force that is responsible for displacing the object through a distance x and giving it a final velocity v. So we can say F equal to ma, and x can be replaced by this quantity v squared divided by 2a. So the work done on this object in giving it a velocity v is W equal to F times x. That will be ma times v squared over 2a, and you can see a and a will cancel, and that will be 1/2 mv squared. Now listen to the statement I'm going to make here. The work done on an object of mass m, in order to give it a velocity v, equal to 1/2 mv squared. And it is this quantity we call the kinetic energy of the object, because this is a measure of the work done on the object to give it that velocity. That means that work has been done on that object. It has now that much of energy. That means if you now try to stop it, it will do work on you. If you stop it, it will do this much of work on you. And that is why a bullet kills. A bullet moving with velocity v has a kinetic energy of 1/2 mv squared. If you stand on its way and stop it, all this energy is going to be spent on you. It will do work on you. So how do you define kinetic energy? So this energy that is stored in a moving object is called kinetic energy of the object. And we will represent kinetic energy by the uppercase K. Although in many books and in many parts of the world, kinetic energy is represented by the uppercase T. Now, we're not going to do that. It's easier for us to call it uppercase K. So, our kinetic energy will be represented by the uppercase K. Potential energy will be represented by the uppercase U. Okay. So K equal to 1/2 mv squared, and in a simple sentence you can define kinetic energy like this. Kinetic energy is a measure of the work done in giving an object a velocity v. Also you can say a moving object has kinetic energy, which is a measure of the work it is capable of doing in coming to rest. It is also measured as the work done to bring a moving object to rest. If you try to stop a moving object, it will do work on you. Try to stop a moving train, then you know the ferocity of the work it can do on you.